Okay, so before going to this Avalanche photodiode, just I will give brief introduction about the PIN diode. Already you know that is the PIN diode. What is so why I am discussing again means, so you have to know what is the difference between the APD diode and PIN diode. So what is the advantage among the PIN diode? That means if you compare to the Avalanche photodiode and the PIN diode, what is the main advantages we gained here? Okay, we will discuss those advantages here. Okay, for that just I will give brief introduction about here. So that means in PIN diode, so there are three regions are there. Three regions are there. So one is the P region and another one is the N region. In between, so there is the intrinsic region will be there. So here P plus is nothing but heavily doped P region. N plus is nothing but heavily doped N region. Okay, here intrinsic region is very lightly doped, very slightly doped or not doping. Okay, generally we will use the silicon. Okay, as the intrinsic semiconductor, intrinsic region. Okay, so this is the PIN diode here. This is the PIN diode. So compared to the PN diode, what is the advantage here? So this is the area of the intrinsic region is more. Area of the intrinsic region is more. That's why it captures the more intensity of, that means more light. It captures the more light. Okay, so very sensitive light also it capture. That means whatever less intensity light also it capture, as well as huge amount of light it capture at a time, because this area captured area is high. Okay, that is the advantage compared to the what is that PN diode. Compared to the PN diode, so what is the advantage of PIN diode means width of the depulsion layer is high. That's why it captures the more light. It captures the more light or high intensity of light. Okay. So that's why here, so it captures more light means current also passing high. Okay, so that is the main advantage of PIN diode. Now coming to the, so what is the major disadvantages? So disadvantages here, less sensitivity and no internal gain. No internal gain, and that is nothing but we have to amplify the current. Whatever, suppose whenever less intensity of light is passing, whenever less intensity of light is instant on that photo, this PIN diode, what happened? So very less intensity of current and low frequency, less intensity of light and low frequency of light is instant on that, means at that situation what happened, this electrons energy also so very less. So that means some energy is required to what is that to escape the electron from valency band to conduction band. Okay, so conduction band, so remaining energy is converted as a kinetic energy. Okay, so that kinetic energy is very small, very small if you will take less frequency of light, and if you will take less intensity means, so electrons also, number of electrons also very small. At that situation, so current will be very small, very small amount of current will be there. So for detecting that current, we have to use another amplifier, in the circuit. Okay, so for minority currents, so very small currents, so if you want to calculate the very small currents, okay, so at that situation we have to use the amplifier here, amplifier. So what is the use of amplifier means, it increase the what is that current intensity, amplification current. That means suppose amplitude of current, it will increase the amplitude of current, okay, that is the use of amplifier. Okay, so that means if you want to increase the current value, what we have to do, we have to again connect the amplifier here. Okay, so that is the main disadvantage here. Okay, that is the main disadvantage of PIN diode. Okay, that, and sensitivity also less, and there is no internal gain. Okay, if you want to gain the electrons, if you want to gain the current, so what we have to use, the another amplifier. for reducing these drawbacks. For reducing these drawbacks, here another diode is prepared. That is the Avalanche Photodiode. Avalanche Photodiode. Okay. Now, yeah, I will give just introduction about Avalanche Photodiode. Okay, that is, an Avalanche Photodiode is more sophisticated than PIN diode and incorporates internal gain mechanism so that the photoelectric current is amplified within the detector. It will be very much useful when very low levels of light are to be detected. Okay, so whatever I explained before, that only this. So this is the yeah. So what is the main advantages means here internal gain is incorporated. Internal gain mechanism is incorporated in APD diode. Okay, so due to that internal gain mechanism, so what happened? So current will be amplified within the diode. Current will be amplified within the diode. Okay, so within the diode, if okay, so within the detector means that diode is used as a detector. That's why here we mentioned as a within the detector. Okay, it will be very much useful. Very low level of light are to be detected. Okay, very low level of that means low intensity of light or low frequency of light is instant, and here means that means here frequency should be greater than the compared to what happened, this energy gap. In every case that frequency should be greater than the uh, this energy gap means what is the relation between frequency and energy? So there is E is equal to h nu. Okay, based on we can calculate the energy of the photon. That means energy of the photon is should be greater than the this energy of the band gap, valency band and conduction band. Okay. Mm, so and so one more is here. So we are there is a incorporation of internal gain mechanism. And so because of that internal gain mechanism, what happened, current will be amplified in the circuit. There is no external amplification is required. Okay, and one more thing, uh, okay, this area also high compared to the PIN diode. Area of the so this area also high compared to the PIN diode. That's why what happens, sensitivity of the material also increases. Sensitivity of the material will be increases. Okay, so this is the just introduction of avalanche photodiode. Now construction. Yeah, if you observe that, so in that avalanche photodiode there are four regions are there. This is the P plus region, and this is the intrinsic region, and this is the P region, and this is the N plus region here. Here only N will be there. So this is the N plus region. So here P plus region is nothing but so heavily doped P region. Here N plus region is nothing but heavily doped N region. Okay, and here P region is nothing but lightly doped P region, and this is the intrinsic region. Okay, now coming to the, so how, what is the I will explain you different regions here. Okay, so the configuration is here. So pi plus region and pi region, P region and N plus region. Okay, generally, so that intrinsic region we will pronounce here. So pi region. Okay, already we know that P plus region. Okay, P plus region means heavily doped P region, and pi region is nothing but intrinsic region, and P region is so normally doped here. Okay, normally doped P region, and N plus region is heavily doped N region. Okay, so this is the construction of APD diode. Okay, here given those values. So here pi region is very lightly doped, or hence it is nearly intrinsic region. Okay, now working. So how it will be works. Okay, so most of the instant light pass into the intrinsic region. Already once of so before going to the working, I will explain you what is that avalanche effect. breakdown already we discussed about that. In case of PN junction diode, there is a two types of breakdowns will be there. So one is the avalanche breakdown, another one is the Zener breakdown. Okay, Zener diode will works. So based on the Zener breakdown here, so we'll discuss mainly this is working. APD diode working based on the avalanche breakdown. Avalanche breakdown. Okay, we will discuss that avalanche breakdown, how it will be here applicable in this APD diode. Okay, most of the instant light pass into the intrinsic region through the thin p region, and electron hole pairs are generated in the intrinsic region. Already we know that. So that means here, so if you will take, this is the very thin p region. Okay, so that light is instant on the intrinsic region. So intrinsic region after coming to the p region. Okay, so p region. So after that, so and it is also connected in reverse bias. Under reverse bias, most of the applied voltage drop across the p and n plus region. Okay, p and n plus region. uh, Already we know that that is in intrinsic region. What happened? Electron hole pairs will be generated. Electrons hole pair will be generated in intrinsic region. That light is absorbed by the intrinsic region and electron hole pairs are generated. Electron hole pairs are generated on intrinsic region. Intrinsic region. Okay, with increasing the reverse bias voltage, the depulsion region across the this junction is widens. Okay, here, so there are three junctions are there. Three junctions are there with increasing the reverse bias voltage. So mainly, what happened? Potential difference will be developed. Potential difference will be developed, and depulsion region also increases. Depulsion region also increases mainly on two regions. Mainly on two regions. I will explain you on which regions it will be. So potential difference will be developed. Okay. Under sufficient reverse bias, the depulsion region widens enough to reach uh, reach through to the intrinsic layer. Okay, if you give sufficient energy, so what happened? So the width of the depulsion layer is increases more than the intrinsic region, more than the intrinsic region. Okay, yeah. Now in this condition, the internal field intensity near the junction becomes very high. Okay, so because of what happened, reverse bias, because of reverse bias, what happened, there is the internal field, internal electric field will be increases. That intensity of internal electric field will be increases. Okay, becomes very high, and the junction approaches to the breakdown condition. Okay, what already we discussed, if you apply the more external reverse bias, what happen at the junction? At the junction, it will reaches to the breakdown condition. It will reaches to the breakdown condition. Okay, therefore the electrons and holes, photon generated in the depulsion layer acquires sufficient energy from the field to liberate secondary electrons and holes within the layer by process of impact ionization. Okay, see here. Already we know that. So what is the avalanche photo effect? Avalanche photo effect. Whenever if fastly moving electron. So if strikes to the another electron, what happen? So those electron also will what is that relieve from the covalent bond, and it also act as a free electron. Okay, so what is the avalanche breakdown means? So because of the external field, external field, what happened? Electron will gain the high energy. Electron will gain the very high kinetic energy. Electrons will gain the very high kinetic energy, and it uh, it interact with the surrounding electrons. It collide with the surrounding electrons. Because of that collisions, what happened? Those electrons will be releases. So those surrounding electrons will be releases. So like this, those electrons again collide with the surrounding electrons. Like that, what happened at a particular time? So the current will be increases very suddenly. The current will be increases very suddenly. That is the avalanche breakdown. Avalanche breakdown. Okay, so same here. So at which situation it will be happen means, so at the breakdown condition, avalanche uh, avalanche breakdown will be occur. Avalanche breakdown will be occur. So due to that avalanche breakdown, what happened? Huge amount of current will increases in the circuit. What is the reason for huge amount of current means? So because so more electrons will be released at a time. Okay, more electrons will be released at a time. Okay, now coming to the why those electrons will be released means, here I will explain you. So when light is instant on the intrinsic region, so what happened? So in that intrinsic region, electron hole pair will be generated. Okay, so that released electron passes through this. Yeah, I will explain you here. Okay, so this is the intrinsic region here. This is the intrinsic region. In that intrinsic region, whenever light is instant on here, electron hole pair will be generated, and this electron will move like this direction. Now we are applying here reverse bias. That's why what happened here. So this is one junction. This is another junction. This total is another junction here. Okay. So that means in this junction are already widened because of the reverse bias. That's why width of the depulsion region is increases. Now there is another junction will be there in between P and N region. Here also see here. So if you observe this graph here, so that electric field inside the intrinsic region is so constant. Inside the depulsion region is constant. But if you observe in this region, depulsion region, electric field will be increases. That means this is the internal electric field. How internal electric field will be generated means, here junction will be formed in between P and N region. There is a junction will be formed, and it also connected in reverse bias. That's why what happened. So these electrons and holes are separated by certain distance, and those electrons and holes are accumulated near the regions. That's why because of these charge carriers, here electric field will be generated. So because of this electric field, what happened? This electron here, intrinsic region, electron will be released so due to instant of photon, that is the photoelectron. So photoelectron will be released. So that photoelectron is accelerated by this electric field. That's why what happened here. So because of that acceleration, it gains. That means its speed will be increases. Okay, its kinetic energy will be increases. It gains the energy. Okay, because of this electric field, it gains the energy. So that's why what happened. It will move very fastly. And so this is the breakdown condition here. Here more charge carriers are accumulated here. So whenever this fast moving electron strikes these accumulated electrons, what happened? So those electrons relieve from the material. And what happened here? So more electrons will be released. So this fast moving electron collide with the another electron, and that electron will be released, and released electrons again collide with the surrounding electrons, like that. So at a time more electrons will be released here. Okay, so this is the working principle here. Okay, see here. So now I will read again this. So in this condition, the internal field intensity near the junctions becomes very high, and the junction approaches to the breakdown condition. Therefore, the electrons and holes, that means these are the electrons and holes are the photo generated electrons. Okay. So therefore, the electrons and holes, so because of generation of photo generation, so in the depulsion layer acquire sufficient energy from the field liberated, from the field, yeah, liberated from the field. Okay, to liberate secondary electrons. Okay, so it will gains more energy. These photons are electrons, so gains the more energy here, more energy, and those will liberate secondary electrons and holes, secondary electrons and holes with the layer by process of impact ionization. Okay, impact ionization. So impact ionization is nothing but, so it will be ionized, those electrons will be ionized, so that's why it will be collide with the surrounding electrons, so that process we will call it as impact ionization. Okay, the newly generated carriers are also accelerated by the high electric field. Okay, so because of the, what is that, that interaction, because of that photo electron will be gain the energy. So because of that high energy of the electron, what happened, it will interact with the surrounding electron, those electrons will be released. So those released electrons also, that means newly generated carriers also accelerated by the high electric field, so thus gain enough energy to cause further impact ionization. Okay, so in this device, so multiplication is initiated by electrons. Okay, so that means here, so multiplication process is occur. So initially, so photocurrent will be emitted, that photo electrons will be, so again release the secondary electrons, again releases the secondary electrons. So that means here multiplication will be occurs, multiplication of the electrons will be occurs. So mainly here that multiplication is occurred due to the electrons only, due to the electrons only. Holes generated in pi region drift to the p plus region. Okay, drift to the p plus region, and hence do not take part in the multiplication process. Okay, here electrons will comes in this direction and holes will move like this direction. These holes does not involve in a multiplication process. Okay, so only here, see here, only here electrons are involving in a multiplication process. Okay, multiplication process. Why multiplication is occurs means here internal, due to the internal electric field, intensity of the internal electric field will be increases. See here, so compared to the intrinsic region, in this region, so electric field will be very high. Due to that electric field, these electrons will gain the energy, and those are involving in a multiplication process. Multiplication process here, yeah, here some lines are given. So high gain due to avalanche multiplication effect. Here high gain is due to the avalanche multiplication effect. Okay, and so one more thing is here, so noise is increased. So at the same time, what is the drawback means, noise is increased. Okay, for that what we have to do means, silicon has high gain and but low noise. Okay, if you use the silicon, if you use the silicon material as a intrinsic material, as well as, so this is, yeah, so I will tell the structure here. Yeah, so if you use the silicon indium gallium arsenate, silicon indium gallium arsenate avalanche photodiode, so often used. So that means if you use the silicon as the intrinsic region, so we can reduce the noise. We can reduce the noise here. Okay. So generally, so which type of material we will use means silicon, indium, gallium, arsenate, APD, oftenly used. Okay. So this is okay. This is about the working of the APD diode. This is the working of the APD diode. Okay. Next, advantages of the avalanche photodiode. Okay, uh, here high level of sensitivity as a result of avalanche gain. Okay, sensitivity also very high. Sensitivity is very high, and internal current gain. Internal current gain due to carrier multiplication. carrier multiplication. Okay, so here internal current gain it will be already so that means in case of PN diode we have to use externally some amplifier. Okay, there is no need to use the amplification. Here internal gain is, so internal gain will be occur carrier multiplication. This is the advantages of, so main advantages of avalanche breakdown. So one more here, so high frequency response. Here one more advantage is the high frequency response. And now coming to the disadvantages. There are some also disadvantages will be there in that avalanche photodiode. That is, okay, this first point is not there. Okay, and second point will be avalanche photodiode produces a much high level of noise than PN photodiode. So main disadvantages here, so noise, so high level of, so very high noise will be produced compared to the PN photodiode. So here noise will be very high. Avalanche photodiode noise will be very high. Okay, next point, avalanche process means that the output is not linear. So already we know that. So output is not linear. So linear means it will be increases continuously. Okay, in one particular order. So output is nothing but. So I will tell you what is the difference between the linear and non-linear. Okay. Suppose if you will take linear situation, that will be increases. If it increasing the voltage, current will be increases like this. Current will be increases like this. In case of non-linear condition, so that will be current will be increases but up to particular voltage value. After that, this current will be increases suddenly. Current will be increases suddenly. That means this is a not linear process, because so at a avalanche breakdown condition, what happened? That current will be increases suddenly. So that's why it is a not a linear process. Okay, output is not linear. Output is not linear. So output is non-linear. Non-linear. Okay. So this is the, so main disadvantage. First disadvantage is noise. Second disadvantage is it is a not linear. Output is not a linear. Okay, so mainly two disadvantages are there. Okay, first one is, so noise. So compared to the PN photodiode, noise is very high. So second one is output is not linear. Output is not linear. Okay, now comparison of PIN and so APD diodes. Comparison between the PIN. Yeah, so I will complete this. Now comparison between the PIN diode and APD diode. First one is the, so PIN diode does not have high intensity electric field region. Okay, in case of PIN diode, it does not have high intensity electric field region within the diode. Within the diode, there is a no high electric field, high electric field intensity. But if you will take APD has high intensity electric field region. So within the photodiode, there is a high intrinsic region, high intrinsic electric field region will be there. High intensity electric field region will be there in case of APD diode. So second point, photocurrent. Photocurrent generating is less compared to the APD diode. So if you will take the formula, so here it will be photocurrent is depends on the number of charge, that means charge of the charge carriers, and so and Ne is the carrier number. So here we are taking, so N suffix E, so that means number of carriers will be there. Okay, so it will be depends on the, so charge of the electron is common, and so number of charge carriers. Okay, but here in case of photocurrent generated is compared to the PN diode is more. Okay, so why it will be more means, here there is a another factor will be there, that is the multiplication factor. Multiplication factor. Okay, because of this multiplication factor, so what happened? Current will be very high. Current will be very high. So this is the photocurrent only. So Q into Ne is the photocurrent. So if you here there is a another factor will be there, that is the multiplication factor. So due to that multiplication factor, in case of APD diode, so current will be generated more. Current will be generated more. Okay. And the responsivity of PIN diode is limited. The responsivity of PIN diode is limited. And if you will take APD diode, so responsivity of APD can have much larger values. Okay, so responsivity, so that already we know that formula, responsivity. So what is the responsivity? Means ratio of number of photons by so number of released electrons. Number of released electrons. Okay, so but in case of so PIN diode, so for each photon what happen? Only one electron will be released. One electron will be released. But in case of APD diode, so for if you will take one photon, so there are so many number of electrons will be released because of the multiplication factor. Because of the, that means each electron so collide with the surrounding electrons, and because of that process what happened, so multiplication of electrons will be occur. That's why what happened, responsivity of APD can be increases very high. Okay, and they exhibit lower noise level. So compared to the APD diode, so PIN diodes have noise level is less. Noise level is less. If you will take APD diode, they exhibit higher noise levels as compared to the PIN due to improved ionization and photocurrent multiplication. Okay, so due to this process, so ionization and photocurrent multiplication process, what happened? So more noise will be increased in APD diodes. Okay, and so one more point is here. So response time of PIN is half that of the APD. Okay, so response time of the PIN is half that of the APD. Okay, now in case of APD diode, response time of APD is almost double than the PIN diode. Okay, here response time also in case of APD diode, so very high. Response time also very high. That means it will be respond within the fraction of yeah. So here response time is so almost up. So it will take time, more time to so respond. So in case of APD diode, so it will take more time. Response time is so double. So that means it will take more time to respond compared to PIN diode. That means so PIN diode response is very fastly compared to the APD diode. Compared to the APD diode, PIN diode response is very fastly. Response time here. So responsivity gal, responsive, not here responsivity. So response time. So response time is here less. But in case of APD diode, response time is high. Response time is high. And here one more thing we have to, one more point also, efficiency. Efficiency of the APD diode is so high compared to the, so what is that, PIN diode. PIN diode. So this is about the comparison between the PIN diode and APD diode. Okay, next class we will discuss about the solar cell. If you have any doubts on this topic, you can ask. Okay. So mainly here, so one more thing, we have to take another region. So another region will be, we have to take extra. So in case of normal PIN diode, there is three regions will be there: P plus region, I region, and N plus region. We are taking here one more region extra. Due to this region, what happened here? Uh, Electric field, more electric field will be developed. If you apply the reverse bias, what happened? Your breakdown voltage will be developed. That means due to that breakdown voltage, what happened? So more electric field will be developed in this region. So because of that electric field only, what happened? That is the internal electric